Hey there, how's it going? In this video, I'm going to be doing a full worked solutions for the Mathematics Extension 1 2021 paper. So obviously it would be good for you to have that on hand. You might be coming here to look at a particular question, but whatever the reason, if you're staying for the whole video or not, I'll have the link to the NESA website where you can find the whole paper and their work solutions in the description. All right, so let's have a look at question 1. It says, given the vector from OP equals -3, 1 and OQ equals 2, 5, what is PQ? So let's see if I can remember what they were. We've got -3, 1. That is from the origin to P, and then 2, 5 is for from the origin to Q. So what is PQ? So what is this vector here? So along the X, we're going to have to go how far? We're going to move 5 there and 4 up, so it is going to be 5, 4, which was option C in the multiple choice. Alright, question 2. Which of the following integrals is equivalent to sine squared of 3x? Alright, so this is of the form sine squared nx, which you can get straight off your formula sheet, is going to be half of 1 minus sine and then double the angle dx, which you can obviously write as 1 minus, sorry, my bad, great start. Both sine squared and cos squared go to cos of double the angle, but sine squared is minus instead of plus, and that was option B. Question 3. What is the remainder when this polynomial -x cubed minus 2x squared minus 3x plus 8, when this is divided by x plus 2, so the remainder is going to be given by x plus 2 is x minus -2, so in that form p of x minus a is -2, so by remainder theorem we can just sub -2 in. And we're going to get -8, negative is going to be 8 plus 4, sorry, 2 squared is 4, 8, so that's going to be minus, right? I'll come through with the hard questions later, I promise. Plus 6, plus 8, those two cancel, and we get 14, which was option D. Alright, consider the differential equation dy dx equals x on y. Which of the following equations best represents this relationship between x and y? So if dy dx is x on y, we can times y up there and dx up there, integrate both of them. So if you illustrate in forward integration, y squared on 2 equals x squared on 2 plus some constant, I'll just label C1, and then to clear this denominator of 2, we can times throughout everything on both sides of the equation by 2, so we're going to y squared equals x squared plus some constant times 2 is just going to be some other constant. Let's call it a different one, but it's of the form y squared equals x squared plus something, which was option A. Question 5. For the two vectors OA and OB, it is known that the dot product of OA and OB is less than 0. So which of the following statements must be true? So you have to just decipher from the options here. It's not really a problem. I'll do the problem and see which answer it matches with. Either OA is negative and OB is positive, or basically the other way. So that's confusing these as like just constant values, like a positive times a negative is a negative, or a negative times a positive is a negative. So it's not option A. Option B, the angle between OA and OB is obtuse, so that's going to be the correct answer, because like the dot product will be 1 if they're aligned, negative 1 back here. It'll be positive if they're in between 0 and 90 degrees, or it's obtuse if it's in between, it's negative rather if it's in between 90 degrees and 180. So just to go through the other ones, C, the product, the magnitude of OA times the magnitude of OB is negative. That's obviously false because the magnitudes are both going to be positive. And the points O, A, and B are collinear, so that's only going to happen if well, it's only have to be a constant multiple of the other, but in this case, that'll only happen if they multiplied together to give 1 or negative 1. They were like opposites in the opposite direction. So that one, just going through each of the options, is going to leave us with B. Alright, question 6. The random variable x represents the number of successes in 10 independent Bernoulli trials. The probability of success is p equals 0.9 in each trial. Let r equal probability that x is greater than or equal to 1. Which of the following describes the value of r? So r is either greater than 0.9, equal to 0.9, in between 0.1 and 0.9, or less than or equal to 0.1. Alright, so probability that x is bigger than or equal to 1 is going to be equivalent to 1 minus like the 1 minus the complementary event, right? Because this is obviously a whole range of possibilities. If there's 10 trials, then it could be, this is going to be the probability of whatever it is for 1 plus 2, 3, 4 through to 10, which is obviously a lot easier to just find the complement 1 minus the logical opposite of that will be if x equals 0, and then just going straight off the formula sheet, we'll get 10c0 times p to the 0, which the probability in the question was 0.9 times the complement of that to the power of 10. And if you put that in your calculator, you get, that's going to be 1 times 1. So we're getting 1 minus 0.1 to the 10, which is, that's not repeating, there's just a bunch of 9s, but it's that means that it's bigger than 0.9, which was option A. Alright, which curve best represents the graph of the function f of x equals negative a sine x plus b cos x, given that the constants a and b are both positive? We've got f of x equals negative a sine x plus b cos x. So I would notice that if we sub 0 in, negative a times sine 0 plus b times cos 0, well, sine of 0 is 0, and cos of 0 is 1. So that means that the y-intercept is going to be the value of b, and given b is positive, that means it has to be above the x-axis. So that cancels out for us the possibilities of A and C. So we're choosing between B and D. Then I would differentiate this. So our negative sign is going to differentiate to negative cos plus minus B times cos is going to be negative sine. And likewise, if we sub 0 into this, sine of 0 is going to be 0 and cos of 0 is going to be 1. So we're going to be left with negative a times 1, which is negative a. So since the derivative at 0 is negative a is positive, so negative a is negative. So that means that at the point where x is 0, the curve is decreasing, and that means out of the possible options, it would have to be the graph that looked like this, where it's positive y-intercept, but it's decreasing, which was option D. Alright, I might start to make some room here. Question 8, we've got the diagram, shows a semicircle. So the semicircle is centered at 3, 2, and has a radius of 2. I'll draw that up in a moment. Sorry, has a radius of 1. There's heaps of 2's in this problem, so that's 2, 2, and that's 4, 2. Then it says, which pair of parametric equations represents the semicircle shown? So it gives a list of options, x in terms of sine or cos, and y in terms of sine and cos, plus some with the plus, some with the minus. Obviously, should be looking at the paper. But all of them have the options where t, the parameter is in between negative pi on 2 and pi on 2. So for t in between negative pi on 2 and pi on 2, if we consider the unit circle for this range of values, then we have that cos of t is going to be the x coordinate, is just going to be range between 0 and 1, and similarly sine of t, the y coordinate, is going to range between negative 1 and 1. Now if we check our semicircle, we want x and y coordinates to be, our x coordinates are in between 2 and 4, and for the range, these are in between, that's 1 down to there, in between 1 and 2. So what we want to do is, if we can manipulate these inequalities such that we can get, them in between to match up the domain and range for these certain values of t, then we can equate the chunks in the middle for x and y. So you might notice here that cos t is kind of spread over an interval of 1 like y. So we might want to try and manipulate this inequality to get it like this. So how can we go from 0 to 1 to 1 to 2? Well, we could add 1 to everything, which would give us 1 plus cos t 2. Unfortunately, there is no options with 1 in them. They are all plus 3 and plus 2. In fact, they're all plus 3 and plus 2 for x and y. It's just which one matches with cos and sine, and whether they're positive or negative. So the other way we could manipulate this inequality to get it like this is if we multiply throughout by a negative. So that's going to reverse the order. Reverse the order of the inequalities. And then now if we add 2 to all of these, we're going to get 2 . And then just writing them in the other order, in the order of the number line. We're going to get 2 minus cos t for values of t in between here and here will give us values in between 1 and 2. Likewise, you can do a similar manipulation here. If we times through by negative, and then I'll Alright, so that's timesing through by a negative. I'm going to flip the order, but then I'm just going to rewrite them left to right. And then we can add 3 to all of these. Which equates out there, so that means we've got right, so the x coordinates, right, as we move along the curve, they will go in between 2 and 4 values of t going in between negative pi on 2 and pi on 2. And likewise, as we move along the curve, we can get the y values will go between 2 and 1 for whatever values of values of t ranging between negative pi on 2 and pi on 2. So that was option C. All right. Question 9. All right. Which graph represents the function y equals inverse sine of x? Okay, so for inverse sine or arc sine of x, we need to take input values from -1 to 1, and sine x, we can input any x value in, and the output from any x value into sine x is going to be an output value of -1 to 1. So that means that the domain for this whole function is going to be all real x, because it's like safe to put in any x value into sine x, and then this only gives us outputs negative from -1 to 1, which are safe to put into the inverse sine function. So then we have to deal with what does the rest of the graph looks like. So that just eliminates option C, which is a graph like, just to quickly sketch it, is a graph like that. So just to clarify, this isn't the answer. Right, so that's going to go up to pi on 2 and down to negative pi on 2, and from 1 to -1. So that option there is going the other way. It's if you've got sine of inverse sine of x. Sorry, that should be, I think. Yes. Right, because basically like an inverse and a function will cancel each other out to just give you this x value. Well, it's not that straightforward. But this basically kind of it's going to look like if these kind of cancel each other out, then we're going to get the equation of y equals x, but only for where the domain is defined for the function. So that is the graph of if they were switched. I guess I can leave that there, because what we're going to do is extend this. Okay, so like I said, this will keep continuing, right? We can keep putting any x values in here that we want. So if we look at option D just keeps extending this line. So that would be like if you recognize that any x input value is fine, but you just simply equated out, oh, inverse sine and sine cancel each other out, so we get the equation of y equals x. Well, no, the range of inverse sine still has to be in between negative pi on 2 and pi on 2. So that knocks out D. So we're dealing with A and B. So A and B is like, A is zigzagging up and down, and B is kind of got this repetitive bits going here and here. So the question is like basically what's happening up to, I think it must be up to 3 pi on 2. Right, what's happening up to in line with 3 pi and 2, and then once we figure that out, we've got a distance of 2 pi, and then it's going to be, this is periodic, sine is periodic, so we're going to just keep repeating this pattern. So is it zigzagging, or is it kind of doing these lines here? I mean, if you're not really sure how to choose between options A and B, you could just really test a random value. So let's say, for example, pi. So if we did sine of pi, we'd get 0, and then arc sine of 0 is 0. Okay, so that gets us that point, but that doesn't really distinguish between whether we're zigzagging or we're going up here. So the question is like in between pi on 2 and pi, do we have like this kind of action with these parallel lines, or are we zigzagging down? So again, you could just test a value, say like what would be in between, like 3 pi on 4. And basically what this will end, like you can test a value and you'll see that it's going to be a positive value. But basically what's happening is that since sine x is equivalent to sine pi minus x, if you don't know that trig identity, maybe you could think of it graphically, like sine of negative x flips over the y-axis, and then plus pi is going to shift it to the left by pi, which will line up with the graph of sine x. And so that means that if we take inverse sine of pi of x, these will like cancel out, and then for then that region will have the graph of pi minus x, which is with a negative gradient, where the y-intercept up here would be like pi, and then that, like I said, is going to be periodic and keep repeating, right? And that was option A. So I got a bit rambly there, but hopefully all that kind of thinking about it was helpful. Maybe not. All right, question 10. The members of a club voted for a new president. There were 15 candidates for the position of president, and 3,543 members voted. Each member voted for one candidate only. One candidate received more votes than anyone else, and so became the new president. What is the smallest number of votes the new president could have received? And then we've got the options 236 through to 239. Okay, so by using pigeonhole principle, we just want to start with 3,543 people voting divided by our 15 candidates, which gives us 236.2. So this is where one misconception is going to be, selecting A because, hey, that number rounds down. But then we need to round up no matter what for pigeonhole principle. So that would be 237, so that might trip people up as well. But we've got to actually think in the context of votes. If we now do 236, like if 236 votes go to each of the 15 candidates, that only accounts for 3,540 of the votes. And since there's 3,543 voters, there's the smallest number would be everyone equally gets 236 votes, and then there's 3 more votes left over. So those 3 votes could go to 3 different people, and there'd be 12 people with 236 votes and 3 people with 237 votes, but then no one's a clear winner. So that means we could have all 3 of those votes going to someone else, but not the smallest amount. The smallest amount would be if 2 votes out of those extra 3, if 2 votes went to the winner and 1 went to the other person. So therefore 236 each distributed across the 15 people, plus with those leftover 3, 1 to the runner-up and 2 to the winner is 238, which was option C. Alrighty, now we start to get, the first one's this is possibly like the easiest question ever in an extension paper coming up. Eleven, find this expression. I mean, yeah, it's using vector notation, but like, you could probably give this to a year 8 student, and if they didn't know what to do, they'd probably just like collect like terms, right? 1 plus 2 is 3, and 6 minus 7 is -1. Okay, I guess it's like the warm-up mark. Sorry, I'll have to remember that these are now. Parts, so 11 parts A. Alright, 11 parts B. We are expanding 2A minus B all to the 4. Okay, so we're going to get our coefficients 4C0 through to maybe I should have rubbed out the book before this one. Or really they're just going to come from Pascal's triangle, right? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So that's going to be 1, 4, 6, 4, 1. Then we're going to get 2A all to the 4, and decreasing powers here to the 3, 2A squared, 2A to the 1, 2A to the 0, and then going the other way, we're going to have negative B to the 4, 3, 2, 1 to the 0. So we're going to have 2 to the 4 is 2, 4, 8, 16 times 1, 16, 8 to the 4. We're going to have plus and minus is going to be negative. That's 4, 2 cubed, 2, 4, 8 times 4 is 32, A cubed B. So you can see that the negatives and positives are going to alternate here with the powers. 2 squared is 4, 4 times 6 is 24, A squared B squared. Sorry. Yeah. 4 times 2 is going to be 8. We've got a and b cubed, and 1b to the 4. Alright, so that one was fairly straightforward. I guess it's the starting end of the short answer, so a fairly routine problem there. Okay, 11c, we've got use the substitution u equals x plus 1 to find this integral, so I'll write that down. And we are using u equals x plus 1. Alright, so obviously that means we're going to replace the square root in there with u. So to replace dx, we've got du dx equals 1, which means du equals dx. And then if we've got u equals x plus 1, then if we might make x a subject and minus 1 from that side, we've got this x here is replaceable with u minus 1. Now if we distribute the square root u as u to the half, we're going to get u to the 1 times u to the half. It's going to be u to the 3 on 2 minus 1 times u to the half du. So now we've just got to use our power rule. So add 1 to the power and divide by the new power. Add 1 to the new power. So find the new power rather, divide by the new power, plus constant of integration, and then we can replace u back with x plus 1, and then our denominators are going to be square roots, and then these powers are still going to be left here. So we're going to have 2, this bit here is going to be root u to the 5, and u is x plus 1. Minus 2 root x plus 1 cubed plus c. So that was worth 3 marks. Fairly easy 3 marks to grab there, because it's fairly straightforward as well. Okay, D, we've got in question 11, a committee containing 5 men and 3 women is to be formed from a group of 10 men and 8 women. In how many different ways can this committee be formed? So we've got 10 men choosing 5. We've got 8 women choosing 3. Times them together is, I don't know, some number, put it in your calculator. And when I did the solutions myself, I didn't even bother to put in my calculator. But, just for the sake of getting the same thing, hopefully, as old mate NESA, 14,012. Alright, 11E, we've got a spherical bubble is moving up through a liquid as it rises. The bubble gets bigger and its radius increases at the rate of 0.2 millimeters per second. At what rate is the volume of the bubble increasing when its radius reaches 0.6 millimeters? Express your answer in cubic millimeters per second, rounded to 1 decimal place. Okay, so we're given in the question, it's spherical, so we've got, this is 11E, v equals 4 on 3 pi r cubed, straight off the formula sheet. And we have its radius increases. So we know that in the question we're given dr dt equals 0.2, and the goal of the question is to find at what rate is the volume increases. So we want to find dv dt when r is 0.6. Okay, so we should differentiate volume with respect to radius. So if this is just a constant, bring the 3 down, we'll cancel out with that 3, so we're going to get 4 pi r squared. Oh, look at that, surface area of the sphere. That's funny. And then we know that we want to find dv dt, which will equal like dv on dt, with a dr here will cancel. And so dv dr will be this expression when r equals 0.6 times 0.6 squared times dr dt we're given in the problem is 0.2. Which to one decimal place should be 0.9. And we had millimeters everywhere, so all the units match up all well and good. Right, 11F is a just straightforward contextless integration problem. I think I got that right. So we've got the integral from 0 to root 3 of 1 on root 4 minus x squared. Okay, so the 4 here is 2 squared, so this will go straight off the formula sheet. So you've got a squared minus x squared, so that's going to be inverse sine of x on whatever that thing is squared 2. And we're going to take that from 0 to root 3. So plugging root 3 in, we're going to have root 3 on 2 minus 0 on 2. Root 3 on 2 is going to be 60 degrees, which is, again, you can look on the triangle on your formula sheet, which in radians is pi on 3 minus 0, inverse sine of 0 is going to be 0, and so we just get pi on 3. Alright, 11G. By factorising or otherwise, I guess by like guess and check or something. I think factorising is going to be the approach. Solve this trig equation. 2 sine cubed x plus 2 sine squared x minus sine x minus 1 equals 0, where x is in between 0 and 2 pi. Okay, I personally don't really like this question because, well, being in the Extension 1 course, because it's fairly, I don't know, it just doesn't feel like there's anything Extension 1-y about it. But I think it's technically there's a syllabus dot point that says something to the effect of solve trig equations by factorising, but I mean, I assume that more difficult things than like this, but nonetheless, so we'll just group in pairs. So we've got 2 sine squared x outside of sine x plus 1. We've got minus a sine x plus 1. minus 1. So we've got sine x plus 1 outside of 2 sine squared x minus 1 equals 0. So we've grouped in pairs, we've taken out like the big factor. And then by null factor or something times something equals 0, either sine x can be -1 or here we've got, if we 2 sine squared x minus 1, so if we add 1 to the other side and then divide by 2, when does sine squared x equal half? So this one, in between, we're just going in between 0 and 2 pi, so this one is when x equals 3 pi and 2. And then here, opposite of square is plus or minus square root. Oh, my brain got ahead of itself. So square root of 1 on 2 is going to be the square root of 1 on the square root of 2, which is going to be square root of 1 is 1. So 1 on root 2. So let's just check what this is. Right, so I'm going to just take the acute angle first. So that's going to be 45 degrees or pi and 4, and then so we got there, and then the other positive ones there, but then because we've got the negative ones as well, we're going to have there and there. So we're going to have pi on 4 pi minus pi on 4 is going to be 3 pi on 4. Pi plus pi on 4 is going to be 5 pi on 4. And 2 pi minus pi on 4 is going to be 7 pi on 4. So there's the 4 solutions from that bit. And then we've also got our 3 pi on 2, which, to put them in numerical order, is like that. Alright, 11h. The roots are, and then we have some quartic polynomial with a few terms missing, so their coefficients are going to be 0, big old naught. Okay, so we've got x to the 4 minus 3x plus 6 equals 0. The roots of this are alpha, beta, gamma, and delta. What is the value of the sum of the reciprocals of them? So what is 1 on alpha plus 1 on beta plus 1 on gamma plus 1 on delta? Alright, so if we find common factor for these ones, right, we'll get alpha times 1 is alpha plus beta times 1 is beta, 1 alpha times beta. And then if we do this at the same time, we'll have, which order do I want? Gamma plus delta on gamma delta, and then if we find a common denominator of both of these, we're going to get in the numerator the sum of the roots 3 at a time, because we're going to get alpha, beta, gamma plus alpha, beta, delta plus alpha, gamma, delta plus beta, gamma, delta, all over the product of the roots. Alright, so the formula sheet only shows the relationship with the roots and the coefficients for a cubic, but basically the one at the end, alpha, beta, gamma, for the product of the roots for a cubic being negative d on a, or if you look, you've got that term there, so it's basically the same thing, negative d on a, and then if we just keep extending the pattern where we have b, c, d, so e, negative, positive on a. Whoop. These cancel, so we've got negative d on e, and this is a is 1, we've got plus 0x cubed plus 0x squared, so that's a, b, c, d, negative 3 on e6, so that ends up being a half. I think that's it for question 11. So most of those were fairly straightforward. I thought, like, if you just know the content, you just plug away and kind of go at it. Alright, question 12, I'm at for A. I'm going to skip over doing that because it says the direction field for a differential equation is given on page 1 of the question 12 writing booklet. The graph of a particular solution to the differential equation passes through the point P on the diagram provided. The writing booklet sketch the graph of this particular solution. So this is because extension, we do it in writing booklets, but then they've got one question where do it on the paper. I mean, make up your mind, seems a bit silly to me. I would just suggest looking at the work solution provided by NESA. It's basically just draw some kind of curve that makes sense passing through there. That's kind of, tangential, got tangents. You draw the curve such that it's hitting, like, it's going through, having tangents in the direction field. It's just one mark, so there's not much to say about that. Alright, 12, I'm going to need space for this, so I'll read it. It's quite long, take a bit to read it. 12b, a bottle of water with temperature 5 degrees, I guess it's been in a fridge, is placed on a table in a room. I'm guessing the room is not a cold room, it's probably a bit hotter than 5 degrees. The temperature of the room remains constant, there we go, at 25 degrees Celsius. After t minutes, the temperature of the water in degrees Celsius is capital T. The temperature of the water can be modelled using the differential equation, and we've got dt on dt is, as expected, something looking like Newton's law of cooling, proportional to the difference with the ambient temperature. So, where K is the growth constant. Part I, after 8 minutes, the temperature of the water is 10 degrees. That's probably worth noting. When time is 8, the temperature is 10. I need to use that condition. By solving the differential equation, find the value of T when the temperature of the water reaches 20 degrees. Okay, so that means we're going to want to find the equation of temperature in terms of time, like I said, by solving the differential equation, and we'll probably end up using this condition. No. Which one? We've also got, because the bottle of the water when it comes out is 5 degrees, so we've also got when the initial temperature is 5. So we'll end up using both of those conditions to find the constant that shows up when we integrate, and then also with the growth constant K. And then we are going to want to, once we've got that equation of relating temperature to time, then we're going to solve for time when the temperature is 20. So 3 marks, and I think we're going to have to do a fair bit of writing. Okay, so if I want to group capital T there, so we're going to have dt on t minus 25 equals times that up there, k dt. Alright, the derivative of t minus 25 is 1, which is in fact on top. So we can take natural log of t minus 25. That's a constant, so integral with respect to t will be kt plus c. Okay, taking exponentials of both sides, we're going to get t minus 25 is e to the c, e to some constant is just going to be some other constant, times e to the kt. This should all look fairly familiar. Again, quite a routine problem, to be honest. And then if we add 25 over here, okay, and we can remove the absolute value because the temperature is 5 and it's, no, can we remove it? We could sub in the initial condition here with absolute value and let's just normally with the differential equations, because of the context, we'll end up being fine ignoring the absolute values. I'll come back to that in a bit. So let's just find when t equals 0, t equals 5 means we can set this to 5 equals 25 plus a e to the k times 0. And what do we get here? If we minus that over there, you get negative 20 equals a. And so we can now update our equation, 25 minus 20e to the kt. Alright, so now we've got this equation here with our updated value for a, so we can use our other condition when t equals 8, temperature is 10, which means 10 is going to equal 25 minus 20e to the k times 8, which is going to be 8k. If we minus 25 over here, we're going to get negative 15 equals negative 20. If we divide both sides by negative 20, we're going to get 3 on 4. If we take natural log of both sides, I'm just going to write this one now on the other side. And k is going to be exactly 1/8 of natural log of 3 on 4. So again, in exact form, we can update our equation. So now we know that temperature as a function of time is going to be, where were we? This equation, 25 minus 20 e to the 1/8 ln 3 on 4 times t. Okay, and then what did the question actually ask us? Now that we've got the equation, find the value of t to the nearest minute when temperature equals 20. So we're going to set temperature equal to 20 e to the blah blah blah. We'll write it when we need to. And we're going to solve that for t. So again, if we minus this over here, we're going to get negative 5 equals negative 20 e to the blah blah blah. Divide that, negative 20 is going to give us a quarter. So then our 1/8, right, the blah 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 is going to be, we're going to have this bit left over when we take natural log of this side. and then we can find t by just dividing that over. So we got that divided by that. That's a bit of fun. You got the same base. That would be the same as like log base 0.75 or 0.25, whatever it's in the form we want it for our calculator. And if we times the 8 up there, we're going to get 8. So what do we got? 8 times natural log of 0.25 divided by natural log of 0.75, so I get 38.55 blah blah blah, which is around about 39 minutes to the nearest minute. Alright, part I sketch the graph of t as a function of time. Okay, so we've got a bottle at 5 degrees initially, and then it is coming up towards the ambient temperature at 25, room temperature. So this is the equation, T equals 25. Okay, so basically it's going to kind of go up there exponentially. If you think about this, this is an exponential. Negative is going to flip it down this way. If we do, and then if we do plus 25, it's going to like move it up. So we got exponential, it's going to get moved down. That's negative. And then also this, I think if we calculate that, what is 1/8 of? If we do, that's going to be negative as well. Well, it is, because natural log of a value between 0 and 1 is going to be negative. So that's going to actually be e to the negative is going to look like that, and then negative there is going to flip it over the x-axis like that. The times 20 is just going to like scale it, instead of crossing it negative on there, it's going to scale down, and then that's going to move it up like that. But then we're only going from 5, so from this bit up to the this asymptote gets moved up there. So something like that. Now, I was going to say something. Was I going to say something about this? T minus 25. Oh yeah, so when we do this, sorry, this video is going to go for a long while, so and I'm like, I redid I had a quick look before I started through like the actually hard questions later on, that I did, but not these ones. When we get this bit here, I guess we in theory have like absolute value here, and so we have but we have a some value there, which opposite of absolute value would be plus or minus here. But if we've got a constant, then and we're going to sub in to solve for it, well, like a could be negative or positive, so positive or negative of a will be, well, if a is positive, then positive a will be a. Like, it doesn't really matter, because when we solve this, we just find the value of a, and like it happens to be negative. Sorry if that explanation is insufficient, but Yeah, should be right. I think you get the point. Like, it looks weird when you just ignore it for the e to the kt plus c line, but then since you have when you do e to the c is just some constant anyway, so it's going to turn up positive or negative as required when you use the condition. All right, what are we, 12c. Use mathematical induction to prove that 1 on 1 times 2 times 3 plus 1 on 2 times 3 times 4 plus 1 on the product of 3 consecutive numbers equals a quarter minus 1 on 2 and plus 1 and plus 2. Alright, and it says use mathematical induction to prove that this holds for all integers n greater than or equal to 1. Alright, so we just got to step through the procedure. We've got when n equals 1, we've got, well, obviously this term here, 1 on 1 times 2 times 3 equals 1 on 6 on the left hand side there. And then if we check on the right hand side, we've got a quarter minus 1 on 2 times 2 times 3, which is a quarter minus a 12th, which is, what's that? That's 3 on 12 minus 1 on 12 is 2 on 12, which is 1 on 6. So if we sub n equals 1 into the left hand side and the right hand side, we get the same thing. Then we assume true for some k, so we've got 1 on 1 times 2 times 3. I'm not going to bother to write that term. So k plus 1, k plus 2 equals 1 on 4 minus 1 on 2, k plus 1, k plus 2, and now we need to check under that assumption that it's true for the k plus 1 case. Okay, so that means I would normally sub it into the right hand side to kind of like check what the goal is. So the goal is going to be, we get the right hand side of 1 on a quarter minus 1 on 2, k plus 1 plus 1 is going to be k plus 2, k plus 1 plus 2 is going to be k plus 3. So now we'll go back to the left hand side and try and manipulate that together. So we're going to have 1 on blah blah blah, 1 times 2 times 3 plus, and then we're going to have this term 1 on k plus 1, k plus 2 plus then the k plus 1th term. So that's going to be 1 on k plus 1, k plus 2, and k plus 3. Alright, so this bit here, as is usually the case when you're doing an induction question, right, matches that expression there, so we can replace it with that. Oh, got ahead of myself. Minus 1 on 2, k plus 1, k plus 2 is that bit there. We've got plus 1 on k plus 1, k plus 2, k plus 3. So if we look where our goal is going for, we've already got that quarter at the front minus, and then we want to, hopefully these fractions will combine to give that one. Okay, so we have a few common factors here. They both have a k plus 1 and a k plus 2, so that means we just need to times 2 up that side and k plus 3 up that side, but just being careful as well that that negative is going to have to do everything on the numerator here, so negative that. So we've got 1 on 4. I'm going to just write this as a plus, but then minus 1 times the k plus 3 plus 1 times 2 is 2, and now we have 2, and we've got our common ones, times that one as well. Okay, we've got negative k, and then negative times positive 3 is negative 3 plus 2 is negative 1 on blah 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 down the bottom, and then we can take out our negative factor. Whoop, as I just say negative. And then we've got a k plus 1 now on the top with 2k plus 1, k plus 2, k plus 3. So obviously we've got k plus 1s cancel out with 1 on the top, and can't be bothered to write again. I'm not doing the test, so which equals the right hand side. So therefore whatever you're meant to write these days. Back in my day, we had to write some big long little paragraph, which was dumb. I'd just go therefore PMI, like you get the point. You asked me what to do, and I've shown algebraically I can do that. All right, 11D. Oh, sorry, 12D. Okay, we've got a function is defined by 4 minus, and then we've got in brackets 1 minus x on 2 all squared for x in the domain from negative infinity up to and including 2. All right, we're going to sketch the graph showing x and y intercepts, find the equation of the inverse with its domain, and then sketching the inverse. So we write it down first. X is here. Okay, so sketching y equals f of x. So y equals this thing. So the way I think the solutions did this differently to me, I manipulated this, something like this. What I do, 1 is the same as 2 on 2, so we've got half outside of 2 minus x all squared. And then I squared the half to bring that out. So 1/4, 2 minus x all squared. Alright, so that means we've got a parabola we've got it shifted, right? That bit doesn't matter, like this is the same as x minus 2 all squared. So it's shifted 2 to the right, it's shifted 4 up, it's concave down, and then this is just kind of like stretched out a meter wider, and then we're just going from, this is going to be the turning point basically in line with here, so should look something like this. So where did I say 2, 4 is going to be the turning point. It's a concave down parabola, and we're going to the left for this this domain given. So we're going to look something like that. Then we're asked for the x and the y intercepts. So if we sub x equals 0 in, we're going to get 1 minus 0 is 1, 1 squared is 1, and 4 minus 1 is 3. And then if we solve when this is 0, so when 0 equals 4 minus a quarter x minus 2 all squared, add this to this side, I guess. Quarter x minus 2 all squared equals 4, times that 4 up. X minus 2 squared equals 16. X minus 2 is going to be plus or minus square root. So x is going to equal, add 2 to that is either 6 or negative 2, but obviously it's going to be that one over there. Alright, part 2, we're asked to find the inverse function and state its domain. So you can do this one of two ways. You can either make x the subject and then change x with y, or what did I just say? You can make x the subject and then change x and y, or change x and y and make y the subject. So which one will I choose? Flip of a coin in my head. We'll just do x equals, I think it's probably easiest in this form, I got it to here, 4 minus a quarter y minus 2 squared. And I've probably done half the work here anyway. But if I kept the 0 minus 8, we'll do it. We've got what? X minus 4 equals negative a quarter y minus 2 squared. I'm going to add this to this side and that to that side, so I get positive a quarter, and then 4 minus x times that through by 4, y minus 2 squared equals 16 minus 4x, y minus 2 equals plus or minus root 16 minus 4x, y equals 2 plus or minus root 16 minus 4x. So I guess the question is whether we've got the positive bit or the negative bit. So they're going to be the two halves of the parabola. Now let's just have a squeeze at the domain of the inverse function is going to be the range of here. So this range is going to be from negative infinity. Since the range here is going from 4 down, that the domain of the inverse is going to be that. But had we gone from, the domain is going to be that way, either way. Sorry, I'm trying to go ahead of myself. So the graph's going to look like this bit. Okay, so 2 that's right. I think I kept on going here. We've got a common factor of 4 we can take out as that's getting squishy. Oh, someone's woken up again. so if we had 2 plus 2 times some positive values here, then we're going to have I just have a major brain fart. You know what I actually like to do is just do the graph first. So this is going to flip over the line y equals x, so that's 2, 4 is going to become 4, 2, that intercept of 3 is going to become that intercept of 3, and that intercept of -2 is going to become that intercept of -2. So this was the graph of y equals f of x, and this is y equals the graph of inverse f of x. So 2 plus 2 times a positive is going to give you like the top half of the parabola, and then 2 minus is going to give you the down there bit. So that means we can, I find it easier just to visualize it, have a look at the graph first. So that means that the inverse function is going to be the 2 minus 2 root 4 minus x. Alrighty, must be getting late. Whew. Alright, question 13. We've got a 2 meter high sculpture. Maybe this wasn't the best idea, trying to do one big supercut. A 2 meter high sculpture is to be made out of concrete the sculpture is formed by rotating the region between y equals x squared, y equals x squared plus 1, and y equals 2 around the y-axis. Find the volume of concrete needed to make the sculpture. Okay, so we've got y equals x squared y equals x squared plus 1 so we get that, and it's rotated around the y-axis, and it makes the bowl kind of shape that you can see in the picture. Okay, so we can find the integral rotated, the volume when we rotate around the y-axis is going to equal pi, right? It's like pi r squared h basically, like formula for volume of a cylinder. So it's going to be from wherever to wherever, and our radius are going to our radii, yes, our radii, because we're like thinking of adding together like a bunch of tiny little cylinders, and each of the radii are going to be the x coordinates. So, and then like the height of the cylinders are going to be the little dy values from wherever to wherever. Alright, so the volume for this is going to be, we can imagine like the volume of is that it? The volume, let's just check my, here's one I prepared earlier. Yeah, so we want the volume from 0 to 2. No, what am I doing? We want the volume from here to here. We want the volume of that rotate around the y-axis and then take away that bit there. So that like the big bit here is going to be pi times integral of from 0 to 2 of x squared, which is just y, and then we're going to subtract this little kind of cut out piece in here, which is going to be pi times the integral from 1 to 2 of, and then if y equals x squared plus 1, then x squared equals y minus 1. Okay, so that's the setup there, and then now the rest is just procedural. So we've got a pi in common, might take that out. Y dy is going to integrate to y squared on 2, which we're going to take from 0 to 2, minus the regular pi out there, and that's going to be y squared on 2 minus y from 1 to 2. That's going to be 2 squared is 4, on 2 is 2, minus putting a 0 in there, minus putting 2 in there is going to be 2 squared is 4, on 2 is 2, minus 2 is 0, minus putting 1 in there is going to be half, minus 1 is going to be negative a half, which is going to be 2 minus plus is 2 minus a half is 3 on 1 and a half there on 2, so 3 pi on 2, whatever the, oh no, we're given the units in the question, aren't we? We were told that this was a 2 meter high concrete thingamajiggy, whatever it was, so that would be in cubic meters. Alright, do I have space to keep going? 13b. When an object is projected from a point h meters above the origin with initial speed v meters per second and an angle of theta degrees to the horizontal, its displacement vector t seconds after projection is, and then we've got the x component is vt cos theta, and the y component is negative 5, so they're just on using 10 for gravity, they're the best of engineers. Negative 5 t squared plus vt sine theta plus h. A person standing in an empty room which is 3 meters high throws a ball at the far wall of the room. So here's our room, 3 meters high. The ball leaves their hand 1 meter from the floor. And 10 meters from the far wall. So we've got the far wall over here is 10. The initial velocity is 12 meters per second at an angle of 30 degrees to the horizontal. So this v equals 12, theta equals 30 degrees. We don't even have to derive the equations. How fun. It's kind of like the easiest projectile motion problem. Do not prove this, not all capitalized. Show that the ball will not hit the ceiling of the room, but that it will hit the far wall without hitting the floor. So that means our projectile is going to do something like, I imagine it's going to go past halfway. So it's not going to go too high and miss, so it's going to miss the roof. That's the worst parabola I've possibly ever drawn. And it's going to be above the x-axis at 10. So there's a few ways you can do this. I normally really like working with the Cartesian equation, so I'm going to get that out first. So we've got x equals vt cos theta, which v is 12 and cos 30 degrees is root 3 on 2. So 12 times root 3 on 2 is going to be 6 root 3t, which if we make t the subject is going to be x on 6 root 3. Then the y component, we're going to have negative 5t squared. So negative 5, I'll just write it down, t squared plus vt sine theta plus h. T squared we can replace with this, so we're going to have x on 6 root 3 all squared plus v is 12, x on 6 root 3 for t, sine theta, sine 30 is half, plus an h, the height it was thrown from was 1. So we've got root 3 squared is 3 times 6 squared, 36, 108. So we've got negative 5 on 108 x squared. We've got 12 on 6 is 2. Is that right? 2 times a half is 1, so we've got just x on root 3, so I'm just going to write that as 1 on root 3 is the coefficient of x, plus 1. Okay, so to show that it doesn't hit the back wall with this is fairly straightforward, because we can just sub in when x equals 10. And find what y equals. Which, what do we get? Negative 5 divided by 108 times 100 plus 10 divided by root 3 plus 1 is, I get 2.14, blah, 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 which is positive, right? So that means it doesn't, when you sub, since I've got the equation here, the Cartesian equation y in terms of x, we're parabola, right, and I've subbed in when x equals 10, then that gives us that the y coordinate here is 2 and some point something, so it's, it hasn't quite gone there. Sorry, it has hit the far wall rather than, like if it hadn't hit the far wall when I subbed x into the equation, right, this equation is going to keep continuing, and it would have negative values. So if when I subbed it in, it's like gone up and come down, and when I subbed in x equals 10, it had a negative value when that would mean it didn't hit the back wall, because it would have kind of hit the floor somewhere earlier. Alright, so we wanted to see that it did hit the back wall, but it did not hit the ceiling. So since I've got the Cartesian equation, I could find the y coordinate of the vertex. So since I've got it in general form here, I can find the x coordinate of the vertex by doing negative b, so negative 1 on root 3 on 2a, so 2 times negative 5 on 108 and then I can substitute that into the equation. Right, I can put this fella, in there and there, and this time if I get a value less than 3, then it hasn't hit the roof. So I'm going to put this in my calculator as -1 on root 3, and then that whole thing on 2 times -5 divided by 108, and I get around about 6.2. So it's past halfway to the wall. Well, I mean, we possibly didn't need to do that, because if the turning point is at 6.2 x coordinate, and that means that to get back down in line with the line of sight where it's thrown out at 1 would take, because of the symmetry, it probably would be another 6.2. So it's not going to get down back in line with the throwing height of 1 meter until it's would theoretically 12.4 meters away, which is obviously past 10, which is before it even drops down to 0. So I could have possibly skipped that bit and then used this bit, obviously written some justification. But then I have this value here, and now if I put that in here, I'm going to have -5 on 108 times answer stored squared plus answer on root 3 plus 1, and I get exactly y equals 2.8, which is obviously less than 3, therefore it didn't hit the roof. Okay. So I guess that one required a bit of like interpretation, but it seemed kind of on the easier end of the spectrum for a projectile motion question. Okay, 13C, we've got this. Ooh. We got this funky looking graph. I don't even know if I can sketch this. Oh, I guess it's kind of, I know what it is. It's meant to be symmetrical. And then these go through here. And then we want to find this, and -2, 2, -2. This is the region enclosed by y equals 2 minus absolute value of x, and y equals 1 minus 8 on 4 plus x squared is shaded in the diagram. Find the exact value of the area of the shaded region. Okay, so this bit on the top is a triangle, so like duh, that bit's easy. Half times base times height, and then the whole, we need this, and because it's symmetrical, you could check that it's an even function. If you sub -x in there, you're going to get the exact same function out. So obviously visually it's reflective over the y-axis, but algebraically as well. Okay, and then we're going to have 2 lots of this bit here. This bit here is going to be, well, because it's below the x-axis, we'll need to take the absolute value of it. So 2 to each of them an absolute value to find the size of that area, since the signed area will be negative, and that bit there will be the integral where it's going from 0 dash there, that's a 2. From 0 to 2 of this thing here, 1 minus 8 on 4 plus x squared dx. Right. Half times 2 is 1, so 4 plus 2 times, so we've got integral from 1 dx is just going to be x 0 to 2, then minus, depending how you like your inverse tan formula, I normally like to have it like this. I'm going to pull out a 4, so I have a 2 on top, and then I've got 2 squared plus x squared. Right, so that's because notice we've got like something plus x squared, a squared plus x squared, and then that 4 is 2 squared, just like we had earlier in the paper. They're not very creative, this one. And then if that's a squared, I want a on the top, which is 2, and then so 8, I can factor out a 4 out there. So when it's in this form, let's just do the rest of this bit here. 4 plus 2 times 2 minus 0 is 2 minus 4 times, and when it's in this form here, I'm just going to get R inverse tan of x minus, x on 2, and we're taking that from 0 to 2. I think it's a bit different on the formula sheet. I think it has 1 on the top, so if you took that 8 out, you'd have 1, but then it's got 1 on a, so if you had 8 times 1 on 2 squared plus x squared, you'd have 1 on 2 inverse tan of x on 2, but 1 on 2 times, if you had 8 out the front, will be the same as you have 4 out the front anyway. Alright, so we've got 4 plus 2 times 2 minus 4 times, we've got arctan of 2, and 2 is 1, and arctan of 1 is pi on 4, minus 0 in there is 0. So we've got, I don't think I've touched them this whole time. Minus 0, done. 4 on 4, done. Absolute value of 2 minus pi, but since pi is bigger than 2, we'll reverse the order inside the absolute value. So now we've got the bigger one minus the small one. So and then we've got 2 times whatever that is. So equals 4 plus 2 pi minus, right now we've got the bigger minus the small one. We can like treat these as just brackets to distribute across. Minus that 4. Which is 2 pi, and I don't think this one had any units, so it's just 2 pi squared. 13C, is that the last one? Are we up to question 4? Oh no, we're not done with 13. Ay. Should be one of those memes when you're trying to get the video to go past 10 minutes. Just casually do a whole paper. I was going to do the advanced and the extension 2 ones all in one go, but this is for a 2-hour paper, and it's so I can't imagine for the 3-hour ones. Alright. The numbers A, B, and C are related by the equation A equals B minus D, and C equals B B plus D, where D is a constant. Show that, instead of part I, show that sine A plus sine C on cos A plus cos C equals tan B. So I think this bit's fairly I think it's fairly straightforward, not too much creativeness needed for this one. All we're literally going to do is replace A and C with these expressions we've given. Sine B minus D plus sine B plus D on cos B, A is B minus D, plus cos C is B plus D, and now we're just going to use a bunch of angle and difference formulas. So that's going to be sine B cos D lowercase? Yeah, okay, that's a bit funny. And then same symbol in the middle, sine D cos B plus sine B cos after I just noted it was not capitalized, cos D, same symbol in the middle for sine, plus sine D cos B. Let's get a different colour. So we're going to have that cancel with that, which means on the next one we're going to have two lots of sine B cos D. So anticipating that this is going to supposedly be tan B, we're expecting a 2 to cancel out with 2, a cos D to cancel out with cos D, and then a cos B, so we have sine B on cos B. So let's see, we've got cos B cos D, opposite sign, plus sine B sine D, plus cos B cos D, opposite sign, minus sine B sine D. And wouldn't you know it, we have two lots of cos B cos D. Which does in fact equal tan B. Alright, hence or otherwise, I think we want to use the hence solve. When does sine, this just casual trig equation, 5 theta on 7 plus sine 6 theta on 7 on cos 5 theta on 7 plus cos 6 theta on 7, when does that equal root 3 for theta in between 0 and 2 pi? Okay, so the thing to notice here would be like, it looks somewhat like this format here, where we've got sine over cos of something plus sine over cos of something. They're the same thing, so they're our A's and there's our C's. Well, maybe, but we know that this from part I, using the hence, is going to be tan B. So we want to try and frame these as tan B, but since they're minus and D and plus D, that would be like 5.5 theta in the middle minus half. So why don't we say that 5 theta on 7 is the same as, if we double, I doubled the wrong one, is the same as 10 pi on 4 14, and 6 theta on 7 is the same as 12 theta on 14. So you can see in the middle here is we've gone from 11 theta on 14, and we've minused that 1 theta on 14, and going this side we've plus theta on 14. So this is like our B, and this is like our minus D to get these our A's, and plus D to get these ones here, right? So this is like minus, that's plus D, and that's B in the middle. So that means this whole like convoluted, ugly looking thing will, we can just replace this whole thing with tan B. So tan 11 theta on 14. When does that equal 3? So when does 11 theta on 14 equal, so inverse tan of root 3 is going to be 60 degrees, or pi on 3. So there, and also down in here, so pi plus, so we've got 4 pi on 3. And then, I mean, we should check that, well, the next one would be like 2 pi plus pi on 3 would be like 7 pi on 3, like maybe when we deal with the 11 on 14, it's gonna maybe knock us in or out of between 0 and 2 pi. Obviously we don't have to worry about negatives, but maybe the next rotation over. So if we times this by 14, we're going to get theta equals 14 pi on 33, and 14 times 4, what's that? Double and double again, 256 pi on 33, which is a bit less than 66, but if we do 14 times 7 is going to be 70 on 33, so that's going to be past 2 pi. So these are our only two answers. All right, we finally finished question 13. Just one more question to go. 1 hour later. Oh, this one. Okay, 14A. This is going to be brilliant. I would recommend looking at the solutions for this question because it's a bit more efficient than my method. But I think it'll be instructive to show the way I approached it. Anyway. One as a cautionary tale in possibly overthinking things, but also because I think my method might be better for if the problem was slightly trickier than it was. Maybe, we'll see. Okay, so we've got a plane needs to travel to a destination that is on a bearing of 63 degrees. Alright, so it needs to do something like this. The engine is set to fly at a constant 175 kilometers per hour. However, there is a wind from the south with a constant speed of 42 kilometers per hour. On what constant bearing to the nearest degree should the direction of the plane be set in order to reach the destination? Okay, so I considered like the end goal as some vector v, and and then we have our plane flying at 175 kilometers per hour, and the wind from the south will be blowing up at 42. So I wanted to find out like what angle that was there, and then if I find out what angle that is there, then the bearing that the plane needs to go on, that this 175 to also add with being pushed up by 42, will give us the net effect of going along that vector at 63 degrees. All right, so we have, I think I called, which one did I call which one? This one we've got U, and this one is W. So using U, V is going to equal U plus W. Now for V, making the angle with the horizontal, here is 27 degrees. Okay, so this is going to be whatever like net velocity it's going at. We're going to have V cos theta, sorry, cos the 27 degrees, on, what am I doing? Vector. V sine 27 degrees for the going over there. U is going to be the 175 cos of whatever the angle we're trying to solve for, 175 sine whatever angle we're trying to solve for, and then this was just like coming from the south, so it's going upwards, so this was this vector here. So yeah. So I set up two equations here. We've got that 175 cos theta plus 0 equals V cos 27 degrees. And we've also got that 175 sine theta plus 42 equals V sine 27 degrees. So if we treat these simultaneously and we want to eliminate V, so we just have an equation in terms of theta. If I label this like equation 1 and this equation 2, if we do, just may as well do sine divided by cos that way, so we get 10. And also we'll have this plus this over this will be easy to treat as well. The plus on the numerator rather than the denominator, so if we do 2 divided by 1, we get 175 sine theta plus 42 on 175 cos theta equals V on V are going to cancel. I may as well write V sine 27 degrees on V cos 27 degrees. Okay, so here we've got 175 sine on 175 cos will just be 10, no, we want sine and cos. This one is just going to be some number. We're going to times the 175 cos up here. Then we've got this here. Okay. So then we've got, if we minus this over here, 175 sine theta minus, I'm just going to call this thing here, like R for convenience, like, I don't know, K or something. K cos theta is going to equal negative 42. Now we've got, like, this is of the form A sine theta minus B cos theta. So we can combine these guys up by, if we do 175 squared plus K squared, where K is this whole thing, and square root it. And that, I think we got either in exact form, all in one go. So that is going to be the coefficient of sine of theta minus alpha, where alpha is inverse tan of our K on 175. And that is going to equal negative 42. So that's with the auxiliary angle. So this bit's like R, and this bit's like alpha. So A sine minus B cos is the same as R sine theta minus alpha, where R is the, like, using Pythagoras theorem on these and doing inverse tan of that on that. And basically, in a bit of a roundabout way, well, oh, actually, this ends up being nice because 175 on 175 cancel, and then we've got inverse tan of tan 27 is tan 27, so we get sine of theta minus 27 degrees equals negative 42 divided by, like, this big ugly thing, 175 squared plus tan 27 degrees times 175, the whole thing squared, square rooted, right? So plus blah, 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 blah. And then if you do inverse sine of that, you get theta minus 27 degrees equals negative 12 degrees. And so theta equals 15 degrees, which means if that's 15 degrees, then the bearing that we need to go along the u vector is going to be 3 digits, 075 degrees. Alright, and then I looked at the solutions and they just did the sine rule on here. So they've just gone, draw up a diagram, 63, still input that 27 there. This was 175 and that's 42, and then sorry, 27 is not in there. Theta is what we wanted to find. Oh, and then by what do you call them? Year 7. I'll get it. Alternate angles on parallel lines means that one's 63. So you've got, instead, you've got this triangle. And then you just use the sine rule on it. Which is hopefully for an Essential 1 student. I don't need to go through how to solve that problem because, like, it's not even like the extra angle without the side you got, like, come on. So I guess, like I said, this is maybe instructive for 2 reasons. One, because maybe if the wind was offered a different angle, then you couldn't use the parallel line there, the alternate angles. So if the wind was like coming at some other random angle, then I think my approach would be there, better there. So it's probably good to still see the steps. But I guess this is a problem where, like, I saw this, I'm like, oh, you know, bearing question, extension 1 test, probably going to be like some vector thing. So I kind of, I guess, what's the expression? Kind of overthunked it, overthought what was required for it, which is fine. You get the right answer, but it's just not as efficient, and we like efficiency with maths. All right. 14b is we've got a logistic equation. In a certain country, the population of deer was estimated in 1980 to be 150,000, and later on it says t is the number of years after 1980. So I'm going to say when t equals 0, population equals 150,000. The population growth is given by the logistic equation dp dt equals 0.1 p, and then it's kind of written in a bit of a funny way, I think. C minus p all over c, where t is the number of years after 1980 and c is the carrying capacity. Good choice of prime numeral there. In the year 2000, so that's 20 years after 1980, so when t equals 20, the population of deer was estimated to be 600,000. Okay, use the fact that c on p outside of c minus p equals 1 on p plus 1 on c minus p. Thank you, NESA, for doing partial fraction decomposition for us, since we're not in extension 2, well, half of us, to show that the carrying capacity is approximately 1,130,000. So we want to basically solve this, or you don't need to, but muck around with this logistic equation and the initial condition and the other bit of information we've got to find the value of C. Okay, so here we're going to want to group up our P's. So we're going to have dp on if we bring that p down there times that c up here, and this c minus p here will equal 0.1 with the dt up here. Okay, and then in the question we're given that this bit c minus p is the same as 1 on p plus 1 on c minus p equals, we can start getting to work on this, that's 0.1 t plus c for constant, let's maybe say like plus, normally we'd have k in here, but yeah, we don't. Okay, k will be fine. It's going to disappear soon anyway. Okay, I like to think of this bit as the derivative of c minus p with respect to p is -1, so if I want a -1 to be there, I'm going to have a negative there. So now we can integrate these. We've got natural log of p minus natural log of c minus p. Oh, do I need to make the argument again about absolute value? Again, it doesn't matter when we're doing stuff with like real world values. Equals, nothing to touch here yet. Natural log of, using log laws, minus means we can divide p on c minus p. Okay, and then we can take exponentials of both sides. P on c minus p equals e to the k is going to be some constant, and then e to the 0.1 t. Okay, so we could keep on going and solve, like make P the subject, or sometimes it can be useful in this case to get an expression for A, to sub in this condition here. So we have P 150,000 on C minus 150,000 equals A e to the 1.1 times 0. 0.1 times 0 is 0. Anything out of 0 is 1. 1 times anything is itself. So that means that A equals this bit here, right? So I'm not going to write that out at A equals that each time, but we do in fact know what A is. Okay, so now I'm going to keep proceeding from here. So if I times C minus P up to here, we're going to have P equals C minus P times A e to the 0.1 t. If I expand this out and bring along with P over here, we're going to have P plus the P times that over on this side equals C times that. Now if we take P out as a common factor, that's either 1 plus A e to the 0.1 t, and then we divide the 1 plus point A e to the 0.1 t down on the other side. And then standard kind of move for logistic equation is, so we just have one exponential term we can divide throughout top and bottom by A e to the 0.1 t. And that means on the numerator, we're just going to be left with C. And then on the denominator, the second term is going to become 1, which you normally write first. And then we're going to have, almost there, then we're going to have then we're going to have 1 on A on e to the positive 0.1 t, which will come up in the numerator as e to the negative 0.1 t. So we're going to have P equals C on, like I said, that divided by that is 1 plus 1 on A e to the 0.1 t. And remember, we do in fact know the value of A. We can sub in this expression here. So we know that population equals 600,000 for C on 1 plus 1 on A is going to be, we know A is this, so it's going to be the reciprocal, C minus 150,000 on 150,000 times e to the 0.1, where t is 20, and 0.1 times 20 is 2. Alright, so now we need to solve this equation for C. Alright, we've got 600,000. If we times all this up here, we're going to have 1 plus C e squared on 150,000 C minus 150,000 on 150,000 is 1 e squared, and that's all going to equal C. So like similar over here, we need to group our P's up, we're going to need to group our C's up. So if I distribute out everything, 600 times that is going to be 600,000 minus 600,000 e squared, and then if I distribute the 600,000 to that and plus minus it over here, you're going to get this C minus 600,000 on 150,000 is 4, so 4e squared. Lots of c. Now if I just write this one to the left and take out a common factor of c, 1 minus 4e squared, we're going to get this whole thing 600,000 minus 600,000 e squared, all on 1 minus 4e squared, which hopefully is like a million and a bit, whatever the question asks. 600,000. Come on. Oh no. 134,000. I was probably too ambitious somewhere. I think I did this slightly different earlier as well. Okay, here's P, that. So this bit here means, 1 on A is the reciprocal of that. What a scuffed video. 600,000. 1 minus e squared. Can I just not use a calculator, right? I think it's one of my e squareds I had as a negative 2 somewhere. Oh, yes. That's meant to be negative there, isn't it? Which means that's negative, which means I'm hesitant. That's negative. I think, let's double check that. Classic. The classic rogue negative is 1131121, which is approximately 1,130,000 as requested. All right, the next one I think is quite. No, it's not that long. I'll probably just run it all out at this point. I think the last 2 problems are actually not too long in the working out front, so I might be able to fit them both on the board. We'll be Dunskies. Okay, 14C. For vector v, show that the dot product of v with itself is magnitude of v all squared. So this should be a fairly standard property that's known, but I guess we're going to use it to get into the next part. So if we say something like let v equal something like that, then we've got v dot v is going to be x times x plus y times y, which is x squared plus y squared, which is the same as the square root of itself squared, which is the magnitude of v squared. with how spacious my writing is, I don't think we are going to end up with, like I said, all this question on the same side. Okay. So with the next question still on the board. In the trapezium ABCD, we've got A, B, C, D. BC is parallel to AD, which is marked on the diagram for us. And the magnitude of AC, oh, sick, yeah. That's point C there, yep. Equals the magnitude of BD. Alright, so not to scale. Alright, we have got let A equal from A to B. So this isn't marked on the diagram, so I'll use blue now. B is BC. And AD equals KBC. So that makes sense because they're parallel, they're going in the same direction, so they'll be a positive scalar multiple where K is positive. So using part I, or otherwise show that 2A dot B plus 1 minus K times magnitude of B squared equals 0. So the fact that we've got these two guys here being equal, and probably means we're going to have to involve them somehow. So we've got that vector AC equals A plus B. I think it was in A and B were in this direction. Equals A plus B. And then we've got BD is going to equal, we've got A and KB, but we're going BD, I believe. Now, I never really remember the way it is for subtraction. I kind of go, okay, negative A is like there, so hold up. I'll get it. Or is it? Yeah, here we go. Negative KB is there. If I translate that up there, that's A plus negative KB. It's going there to there is the same as going from there to there. But I did that the wrong way around, which means it's negative. So it's KB minus A. So from, if we go like up to A, yeah. The most convoluted way of saying it there. Okay, and then we know, because they're marked as equal and given to us in the question, that those magnitudes are going to be equal. So we know that the magnitude of this equals the magnitude of this, so we know that the magnitude of A plus B equals the magnitude of KB minus A. Then, if I square this side, I can square this side, and then using this part here, we know that this is going to be the same as the dot product, so I can say this is the same as A plus B dot A plus B, and likewise this is going to equal KB minus A dot KB minus A. So property of vectors is we can distribute these, distribute the dot product. So we're going to have A dot A, basically like expanding a binomial, to lots of A dot B, because we'll have A dot B plus B dot A, or it doesn't matter, 2 plus B dot B is going to equal K squared B dot B minus 2KA dot B plus A dot A. Now we've got this term here and here cancel. I'll continue up here. And what are we trying to show? We're trying to make 0 the subject, and then hopefully the left-hand side ends up being right. Okay, so here we've got 2A dot B. And now B dot B, going back the other way, is going to be plus magnitude of B squared minus everything over to this side. So we're going to have minus K squared. B dot B will be magnitude of B squared plus 2K A dot B is going to equal 0. So we've got 2 outside of 1 plus K, lots of A dot B plus 1 minus K squared, lots of magnitude of B squared, that we can factor into a perfect square. 1 plus K, 1 minus K, and then we can divide throughout both sides by 1 plus K. So divide by 1 plus K this term, divide by 1 plus K, and 0 divided by 1 plus K is 1 plus K. And so lo and behold, we have 2 lots of the dot product of A and B plus, and then we're left with 1 minus K here, lots of the magnitude of B squared equals 0, which was what was requested. Oh no, there's still 2 more, not 1 more. Oh, perfect, I just fit the whole question. It's a big question. It just fit in my laptop screen. Alright, so 14D. Just lots of readings. I'll probably finish writing this out before I get to it, because I'm too much of a boomer to go cut a video, or maybe just too lazy. Okay, at a certain factory, the proportion of faulty items produced by a machine is P equals 3 on 500, which is considered to be acceptable. To confirm that the machine is working to this standard, a sample of size n is taken and the sample proportion P hat is calculated. It is assumed that P hat is a approximately normally distributed with the mean equals P and sigma squared, so the variance equals P 1 minus P to the N. Production by this machine will be shut down if P hat is greater than or equal to this. Bad if P hat's greater than or equal to that. The sample size is to be chosen so that the chance of shutting down the machine unnecessarily is less than 2.5%. Okay, so less than 2.5% would be P hat being bigger than this corresponds to 2.5%. That's bad, we don't want to shut down. 2.5% in there means, should recognize this as 95% between z-scores of -2 and 2 is 95%, because of the symmetry. 95% off 100% is 5%, split 2.5% either way. So this is saying if it's shut, it will shut down if we want there to be less than 2.5% there, which corresponds to a z-score of 2. Question is, find the approximate sample size required, giving your answer. So the approximate sample size of n, so back in the first paragraph, the sample size of n is taken. So find the approximate sample size required, giving your answer to the nearest 1,000. Okay, so this z-score of 2 corresponds to P hat of 4 on 500. And we want to solve for n here, and a z-score of 2 is the mean plus 2 lots of the standard deviation. And we have an expression for this, and we have an expression for this, so now we've got and we have a value for P, so now we just kind of got to go through the motions. So 4 on 500 equals P, so 3 on 500 plus 2 times. This is the sigma squared is that, so sigma is going to be the square root of P, 3 on 500, times 1 minus P is going to be 497 on 500, all on n. So n is what we wanted, so we're going to solve an equation to find it. So if I minus that over to that side, we get 1 on 500 equals 2 root blah blah blah, times that by 2 means 1 on 250 equals root blah blah blah, square both sides, 1 on 250 squared equals 3 on 500 times 497 on 500 n. So I can times 250 squared. I feel like I've done something wrong. If I times n up there, and I times 250 squared up there, these are still square root, aren't they? That's the square root then. And times the 250 squared up there. And then square everything again. And it's going to be 3 on 500 times 497 on 500 times 250 squared. Squared is going to be times itself, again, and then 250 squared. So I thought something was going to cancel out with that. So we've got 250 squared again, because everything on both sides is being squared, is to the power of 4. Now let's check, we get that. 3 times 497 times 250 to the power of 4 divided by 500 divided by 500. Yeah, I got too hasty somewhere. Professional mathematician over here. Let me just check my previous solution to see where I went wrong. Oh, 2, well, I want to divide that down, so it's going to be 1,000, 1,000 squared times that up there is 1,000 squared. Square everything on both sides. I feel like this is going to make it worse. Hold up. Oh, I've doubled up on. Oh gosh, this is so bad. Because I squared everything on both sides. That 1,000 squared was there, and that was. Don't worry. I came to this video to see the answer to 14D explained extremely clearly. Which is 5, 9, 6, 4, which to the nearest thousandth is approximately 6,000. Okay, so I assume the difficult part of this is meant to be the interpretation of the problem and kind of setting up this equation, and then this is meant to be like the plonking away at the algebra to get to that. So, assuming you're satisfied with my explanation up to there, 4 minus 3 over the same denominator is 1 over 500. If I've got times by 2, divide by 2 is 1,000, then I've still got the square root. I can remove the square root of this whole expression here if I square this side, but if I square this side to remove the square root of this stuff here, I've got to square the other side. 1 squared is obviously 1 over 1,000 squared. Then times n up to this side, times 1,000 up, squared up to that side, and then chuck that in your calculator. Yep, first time, easy. Alright, and cheeky little 2 marker to finish off. Maybe I should rub this away, so there's no evidence in case you're coming in just for 14E. Alright. We've got a function, the polynomial g of x equals x cubed plus 4x minus 2, and it passes through the point 1, 3. Find the gradient of the tangent to f of x, this function, x times inverse of g at the point where x equals 3. So we want our goal here is to find f dash of 3. Okay, so you might be tempted to try and actually find what the inverse function is. That might be difficult with x cubed and an x and then just a number there. So, and it's not actually required, so let's not do that. Okay, so using the product rule here, we're going to have f dash x is going to be derivative of x is 1, so derivative of that times that is going to be g dash of x, inverse g of x times 1, and then we're going to have plus product rule, so we've got u dash v, 1 times that, times v dash u, so the derivative of this times this, so we're going to have x times the derivative of inverse of g of x. Okay, so I guess the question is, what is this expression here? Well, if we let y equal inverse g of x, then we get that that x equals g of y. So if we differentiate g with respect to y, how am I doing this again? No, we want to find, what expression do we want to find? Yes, that's right. I want to differentiate the right hand side. dx dy is going to be g dash, x, that's a function of y, is going to be g dash of y, so dy dx is going to equal 1 on g dash y, and y was our expression for inverse of g, so dy dx is going to be 1 on g dash of inputting g, inverse g of x. Okay, so we want to, that's basically this bit here, right? We let that be y, so dy dx is this guy here. So if we put 3 into here, equal inverse g of 3 plus put 3 into there, times put 3 into here, 1 on g dash inverse g of 1 of 3. Now here we have that, from here we have that if you put 1 into the g function, you get 3, but that means going the other way, if you put 3 into the inverse function, you get back 1. And we also noticed that we also need the derivative g dash of x, so we should find that as well. G dash of x is 3x squared plus 4. So inverse g of 3 we've just said is 1 plus 3 times 1 on, well, likewise inverse g of 3 is 1, so we need to put 1 in the derivative of g, so we need to put 1 into this function here. So 3 times 1 squared plus 4, which is 1 plus 3 on 7, which is 1 3/7. And that's the end of that chapter. So thanks for bearing with me. It was a bit of a long video. I assume most people will be just jumping around for a specific question. Apologies if it's my first time doing a video this long, but hopefully it's beneficial if you do want to watch through the whole thing, as like you pause it and do the paper. Yes, I'm going to question whether I do this for the rest of the papers since the new course, because even though it took me, an hour and a bit to do the paper, to go through and explain each question with me stumbling over half of them as well. It takes a bit longer than expected. So yeah, but that's it for this video. What's my catchphrase? Catch you later.